In previous screencasts, we have examined how to calculate the mean, median and mode. We have also discussed the fact that these are three different measures of centrality. However, this screencast aims to examine when we should use each measure of centrality. In order to determine which method is most appropriate, we must examine the spread of the distribution. So how spread out is our data, or how close together is our data? We need to examine whether there are outliers or not also. I mentioned a moment ago that sometimes we need to establish whether a particular data set has outliers or not in order to be able to determine what is the best measure of centrality for a particular data set. Well, an outlier is a value that's much smaller or larger than most of the other data values in a data set. So if we look at a simple example here of results in an examination of 13 different students, you can see the results detailed here, starting with the smallest value all the way up to the largest value. And if we examine these results, you can see that the bulk of the results lie between 45 and 65. So most of the students got results within that range. However, there is a value at the bottom here, 10, which is much smaller than most of the other data values, and also a value here, 99, which is much larger than most of the other data values. These two values, 10 and 99, are therefore considered to be outliers in this particular data set. The spread of our data can be examined by looking at the shape of our data if we were to display it in a histogram or bar chart. Our data could be normally distributed or bell-shaped symmetric data, which we'll look at in a moment, or it could be not normally distributed or skewed data. These two different shapes of data determine whether we are to use the mean, median or mode as a measure of centrality. This histogram represents bell-shaped or symmetric data. It's called bell-shaped because if we were to draw a line around the outskirts of the bars, it would form a reasonably symmetric bell shape. You can see that it's almost a mirror image of itself on either side. With this type of data, the mean lies in the middle of the data. The median also lies here, as well as the mode. However, with bell-shaped and symmetric data, we usually use the mean as a measure of centrality, as it takes into account all of our observations, unlike the median and the mode. The data presented in this histogram is skewed or asymmetric. If we were to draw a line around it, such as that which we did in the previous case, you can see that it doesn't form a nice bell shape, nor is it symmetric on either side. It is not a mirror image of itself on either side. When data is skewed or asymmetric, such as it is in this case, the best measure of centrality is the median. The reason the median is the best measure of centrality for skewed data is because it is unaffected by outliers. So all of these large values up here are not affecting the median, as if you recall, the median is the value in the middle position of our data. So if we were to lay out all of our data, the middle position would fall here at 8. The mean, however, is not appropriate as it is affected by outliers, as the mean takes into account every observation that we have. You can see from the graphical representation that the median in this case is giving a better representation of the central tendency of the data, or where most of the data lies around. This slide provides a summary of the advantages and disadvantages of the different measures of centrality, as well as a summary of when each is appropriate to use. You may have noticed there wasn't much discussion surrounding the mode within this video. The reason for this is that the mode may not always be present within a dataset, or alternatively There may be several modes within a data set, and so it is not always a reliable means of measuring the central tendency of a set of data. Hence why we tend to use the mean when we're dealing with symmetric data or bell-shaped or normally distributed data, and the median when we have skewed data or data which is not normally distributed.